In 2021, Novatech introduced its Climate Change Keep It Cool initiative. As part of that initiative, we determined it was a good idea to monitor power usage in our buildings. But the problem we have right now is we don't know our electrical system that well. So this is a first power shutdown so we can map the building electrical system. Once we do that, we can know strategic points where we're going to monitor power, and then hopefully with that data, make decisions and monitor those decisions to know where we're doing well and where we need to improve. So today, we're shutting down the power to map the electrical system and installing a couple of pieces of equipment to start with. There will be a second shutdown later. The second shutdown will be for installation of the final metering equipment solution. First, I'm installing the voltage ring for C-phase in this transformer. That consists of a bolt and a lock washer here so it doesn't come off. C-phase on this transformer monitor is blue in color, so you see the blue ring going on the H3 bus bar here. Next, we're installing the rings on B-phase. Since this is a three-wire system, this transformer monitor has us hook up our neutral to B-phase as well, and then the math is done inside the monitor. So you see red and you see white. We are putting those on this lug here, lock washer and nut, so it doesn't come off. Just like C-phase, now we have B-phase done as well. And last for the voltage rings here, we have A-phase on H1. It is black in color, and so we're placing the ring on the lug and then lock washer and nut so it also doesn't come off. So next we're putting on our CT coils. This is a special type of coil called a Rogowski coil. Rather than transferring big current to small current, it is actually using an integrator to change big current to small voltage, which will be then transduced by the transformer monitor. It's kind of like a bracelet. You take it apart, twist it apart, wrap it around the bus bar, and then reinsert it and twist it back in place and make sure the arrow is pointing the right direction. Next, we're going to do the same thing for H2 or B phase. Again, since this is a three-wire system, we have the neutral and the B phase ring CTs put on here, the Rogowski coils. So first I put on the B phase, and second I put on the neutral one. And like before, you break the bracelet apart and then put it around your bus bar, get the arrow pointing in the right direction, and then place it back onto the bus bar. Lastly, we have H1 or A phase. We have one CT on A phase. We break it apart, we wrap it around the bus bar, get the arrow facing the right direction, and then twist it back into place.
We accomplished 3 things today. Primarily, a power study. Now we know which electrical panels feed which parts of the building. The tangible output of the power study is what's called a one-line diagram or elementary diagram. Its job is to visualize how the electrical system is connected together. Using this one line, we are able to plan where we might place more electrical submetering to better understand electrical usage at our facility. The second thing accomplished today was that we upgraded our transformer in our electrical room with a transformer health monitor. In other words, that transformer is now a smart device. We can monitor its health and status in real time, and one interesting output of this is our ability to monitor the electrical power factor of the equipment downstream of this transformer in our electrical system. A quick note on power factor. Simply put, it is the ratio of useful power, watts, to total power, voltamps. A useful simplification of power factor is one of pouring beer into a glass. While that might seem strange, you can see it in that the useful part is the liquid part of the beer, and it represents your useful power, watts. The froth on the top represents your non-useful power, or voltamps reactive, VARs. The total of these two represents all the beer in the glass, or voltamps. Bearing that in mind, we can see from this transformer monitor graph that the building power factor is very poor overnight, as seen in the dips in the graph. The technical reason for this is that the various heavy equipment transformers in the building require magnetization energy, that's VARs, all the time. Since we're not loading it with our workday activities at night, all that's left overnight is the froth on the beer. This makes power factor lower. The third thing accomplished today was some helpful research into what some future Novatech products and capabilities might look like. We are excited to see what that future brings. Stay tuned for updates on Novatech's building power monitoring story, and make sure to visit us at keepitcool.earth and at novatechautomation.com.